The two lessons on functions culminate with a very practical activity, which I think is very important to do. I did this with a group of Year 9 pupils last year. It absolutely fascinated them. There's something about starting, as all the lessons do, from a very concrete, simple thing, and you end up with something very abstract because you go through the steps of, you have something simple and concrete that the pupils do and can think about. They then discuss the maths, and then you then apply the thinking to other patterns of growth. And it really is worth giving your children time to reflect upon this and apply the thinking. So what you need is lots of popcorn. Lots of popcorn. I would give every child, every pair of children or three, a plastic cup with popcorn in, but start with a lot of corn. You can say, well, how much corn is here? You could start with the balloon and rocket, just to flash that up, just to get them talking, just to remember about the what we're talking about, what we need to think about when we're talking about graphs and rates of change, and how we explore, and what does that mean in reality, and how does the graph help us to visualize this. So the lesson starts with a scenario of a story, I think it's true, but it's a legend from the Far East in Babylon, where a king was under siege. He was going to lose his kingdom, and a wise man steps forward and says, Your Royal Highness, I'll help you, I'll win the battle for you, and so he does. And so the king is forever in this guy's debt, or this woman's debt, and says to the person, I'll give you whatever you want, up to half my kingdom, you've really helped me, I'm forever in your debt. Or you could lay it on and just have the narrative and all of that. There is an image that goes with this. And so the guy says, Oh sir, all I want is a chessboard and some corn. And the king kind of looks aghast. What? You could have anything you want. You could even have my daughter, the princess, and become next in line to the throne. He says, No, I just want some corn. And Your Royal Highness, what I'd like you to do is on the first square of the chessboard, I'd like 2 bits of corn, 1 bit of corn, then 2, then 4. And then 8. And every chess square you double. So that's the start of the lesson, that's the introduction. What is really useful for the pupils to do is they have either a big, I've done it on A3, but I think a piece of flip chart paper works, if they have a piece of very large paper with an 8 by 8 grid on it. And what they do is they actually start putting the corn on, and I think it's important for them to do this. 4, 8, and so on. But after a while, the squares become too small for all the corn. So I get them to write on the number that's in the square. So they leave the corn behind and now start looking at numerical patterns. 632, 64, 128. Some children will naturally round and just say, well, 128 is like 130, I'll just double it. Some of them will take a while. So that's an interesting point to stop. You then say to them, why was this man who seemed so clever say such a simple thing? What did he know? What was he able to work out? What was going on in his mind? What was he able to understand? So the first part of this activity is the story, the image of the 2 graphs, but then the children move on to an activity of placing corn on and writing the numbers. You could just leave them with this sheet of paper and don't tabulate it, but it might be worth doing it on the board just to give them a whole class something to focus upon. So the children have played with their corn. Hopefully it's not too much has gone on the floor. I really did this at the start of the day, so I could pick it all up before the cleaners came in if any was knocked over or some of the children had thrown it or put it in each other's pockets. But they've now got a grid with lots of numbers on. How you structure the next, I think, depends on the level of challenge you want, the level of thinking that you want the children to do for themselves. You could give them this or put this on the board, where they're forced to focus on, because what is interesting from the balloon and rocket and the B equals 4A and the B equals A squared, they're thinking about the change that gives them the difference in the shape of the graph. So obviously you've got 1 here, you've got 2, you've got 4, you've got 8. So the increase here is 1, the increase here is 2, the increase here is 4. So they can then focus on the fact that what is this one? The increase is increasing by 2. So they can start to see a parallel symbol, start to see what's happening with the numbers. What you also need to give them is some grain facts. That 200 grains of corn equals 100 grams. 2,000 grains of corn is 1 kilogram. 2 million grains of corn is 1,000 kilograms, which is a ton. Tell them that the king has 200 tons of corn. Because they will start commenting on how big the numbers are actually getting by the time you've done two rows on the chessboard. And you say, why is the king starting to get worried? Why are all these minions coming with barrels of corn? The king has 200 tons. Some of them start to work out that by the time you get past 30, the king's run out of corn. And if you do it in a cumulative way, he's run out of corn a long time before that. So how much corn would it take to fill 64 squares of the chessboard? Suddenly they're getting a sense of how numbers are almost becoming possibly large in a very short time, in front of their own eyes. It's happened. So I remember at one point, I don't know if I was doing O-level biology or A-level biology, when the biology teacher said, breathe in, imagine on your tongue there's 1 bacteria. In 20 minutes that will double. By the time we have next lesson, which is in a day's time, how many bacteria do you think you've got? It's really hard for them to deal with very, very, very large numbers. There's lots of problems you could share with this, but it's the fact that they're suddenly trying to get to grips with very large numbers. And how does that look on the graph? You might want to sketch what that looks like on the graph compared to other graphs. You might want to suggest this question to them. How would this work as a form of space travel? A rocket leaves the Earth at 1 meter per second, but every second it doubles in speed, in distance covered. How long do you think it would take to reach the moon, to reach the sun? Could it do it in a day? And there is a slide showing this information. Yes, no. So you say to them, the rocket leaves the Earth travelling 1 meter a second. That's a bit like Usain Bolt. Bit slower than Usain Bolt. Yeah, it's a rocket, but every meter it travels, it doubles its speed, doubles the distance it can travel. Sorry. How long would it take to get to the sun? And the end of the lesson, there is a series of images that bring this into everyday context. The one I use, coming from a biology point of view, is a sperm fertilising an egg. When a sperm fertilises an egg, you've got 1 cell. When a baby's born, if you take a drop of blood, there are about 5.5 million cells in that drop of blood. How have we gone from 1 to so many? How many in a baby's body? What about stick insects? What type of increase is that? 1 stick insect, and if you've ever had stick insects, you know you're blighted. 1 stick insect lays 1 egg. It's a clone that can lay an egg. So if a female stick insect reaches maturity and lays 50 eggs, when those 50 eggs hatch and they reach maturity, they each lay 50 eggs, and that, you could say, that could take 4 months. How many could you have after a year? What about if someone's ill on a plane and infects every other person, and they infect every other person they meet? What about a virus on your phone that gets into your phone book and then goes into other people's phone books on their phone book? How quickly would that spread, cover the whole country? I think it's important, or even nuclear chain reactions. There's loads of examples you can give them of numbers increasing so very, very quickly. And it brings in a sense of wonder and a sense of, wow, as I got when I was in year 6 and watched owls. The sense of travelling at light speed, how fast is that? I think we can't underestimate how important that is to sow those little seeds that will germinate in children's minds as they look at the world, as they think of themselves mathematically. Also, as they get into year 8 and they're in year 8 and they start to need to deal with these difficult concepts that you can't teach them. They've got to be able to understand it. You've got to prepare their minds to cope, to dealing with some really abstract concepts. Right? Mm-hmm.